Bismillahirrahmanirrahim. Welcome to Basic Engineering Mathematics. This is chapter number 2 and second episode we are going to discuss of the fractions. The chapter is the fractions, and we had already discussed the fractions introduction in the episode 1, and this is the episode number 2, and let's take a look about the topics that we are going to discuss today. And these are the topics that we are going to discuss today. Number 1, addition, and number 2, subtraction of some fractions. And we already discussed how to deal about the fraction, and now we are trying to add to do some operations, to perform some operations on our fractions. And let's see what happens. And at number 2 we are going to discuss some problems for the better understandings as usual, and at the end ultimately I will give you some homework. And this is the simplest way of simplest look at the subtraction of the fractions. Fraction means some portion, some partition of a whole segment or some portion. For example, as in you know, when we are solving some problems in the physics or in other subjects, while you solve some problems, you may notice that when we want to add or subtract two quantities, we must have to be the same units. So we will try to convert one quantity to in the units that the other quantity have. So same is the case here. For example, this circle has 1, 2, 3, 4 and 5 partitions, and we will try, if our second circle have also 5 partitions, then we can operate, we'll try to we can add or subtract. Basically we can operate in this way, because if our base is same, means to say the unit in this term that we can say that as in physics there our units must same to operate between two quantities. So here we can only apply our operations of addition and subtraction when our both the quantities have the same partitions total. So here in this case these are the 6 partitions here, and you can see that here also 6, and this usually partition is you can see the partitions, total partitions, these are total. So total can be denoted in the denominator. So means to say that if the denominator is same of the two quantities, it means they have the same units in terms of physics. So you can see that it has 4 shaded portions and it has 1. So simply 4 shaded portion minus 1 is the 3 shaded portion. This can, remember, this can only be we can treat only in this way if our total is same, means to say our denominator is same. And this is the example, f2 divided by 9 plus 5 divided by 9 is equals to 7 by 9, but only if our denominator is same. You can see that this is also 9 and this is also 9, so the denominator still remains 9 as in our previous example. So the total partition 1 2 3 4 5 and 1 2 3 4 5, and total partitions are still 1 2 3 4 5, means to say denominator still remains the same, but the numerator will change. 2 plus 5 is equals to 7. Same is the case here. 8 plus 1 this is the 3 plus 1 4 and divided by 8. It can be still further simplified by dividing with the simplest prime number, that is 2. So after dividing by 2, 4 can be cancelled to 2 divided by 4. Then further if we continue this process, then it becomes 1 by 2, and this is the simplest form, and this process called cancellation or cancelling process. And if denominators are different, then of course we should take the LCM, that is called the least common multiple, and least common multiple is already explained in chapter number 1 in the basic arithmetic. In shortly, making the denominators the same for each fraction, that is the key point here. The lowest number that both the denominators divide into is called the lowest common multiple or LCM. For details, visit chapter 1 basic arithmetic. Problem number 1, simplify 1 by 3 plus 1 by 2. You can see that these are the two numbers that the denominators are not same. If the denominators are same, then we can simply add the numerators. But first of all, we will try to make the denominator same. To make the denominator same, we should have to multiply with the both numbers with any number to make the denominator the least common multiple, so that it should be the same. Let's see the process. Step number 1, taking LCM of 3 and 2, and that is 6. So we should try to make the denominators of 6 of the both cases. 1 by 3 is multiplied by 2. If denominator 3 is multiplied by 2, then it becomes 6. So we will try to make the both the denominators same. First one is 1 by 3. So 1 by 3 is if multiplied by 2, that becomes 2. 2 is multiplied by both terms, 1 and 3 also. 2, it becomes, numerator becomes 2, and denominator when multiplied by 3, then it becomes 6. It graphically represented here in this case, you can see that 1 by 3 means the one portion out of total 3 portions, and if the portion of total portion are increased to double, and then shaded portion also get double, and it becomes 2. And this is the second term here. In the previous slide, you can see that 1 by 2, this is the 1 by 2, and if we want to also change the denominator to the least common multiple, that is 6, we should need to multiply this 2 with 3. So 3 is multiplied with the term 1 by 2. If denominator becomes 3 multiplied by 1, 3, and the denominator becomes 3 multiplied by 2, that is 6. So 1 by 2 means half, and if the total portion are 6, then also shaded portion will become 3 to make the equation balance. And step number 3, simply 1 by 3 is equals to 2 by 6 plus sign as it is. 1 by 2 here becomes 3 by 6. So now you can see that we had changed these terms to these terms. Remember, these are the same terms. If we will try to divide by the simplest prime number, lowest prime number, means to say, let's say the lowest prime number we can divide here by 2, then 2 can be cancelled out by cancellation process, then this will become again 1 by 3, and this will become again 1 by 2. We just made this to we just convert this into this term basically to simplify and to make the denominator same. And you can see that now their denominators are same, and we can simply add them their numerators, 2 plus 3, and answer is 5 plus 6. And this is the graphical representation, as you had already seen the graphical representation in the first slide. This is the same. For example, here the total partitions are 6, and these are the 2 by 6 means the 2 shaded portion plus sign as it is. Then the 3 partitions out of 6 means 3 shaded partitions out of 6 is equals to 5 total partitions, 3 plus 2, 5 out of 6. And this is another question, 3 by 4 minus 7 by 6. I will try to solve this in another way, and this is the simplest way and fast and quick way. Taking LCM of the 4 and 16 is 16. This is the lowest common multiple. 4 multiplied by 4 is 16. 16 multiplied by 1 is equal to 16. So this is the LCM. So first of all, write the LCM in the denominator, okay? And then in the numerator, write 3 as it is. Number 1, write 3 as it is. You can see that. And then how many times if I multiply the denominator of the first term to become it 16, to make this 16. 4 multiplied by 1, 4. 4 multiplied by 2 equal to 8. 4 multiplied by 3 for 12, and 4 multiplied by 4 equal to 16. So 4 multiplied by, if 4 is multiplied with 4, then it becomes 16. So here if 4 is multiplied with 4, then it becomes 16. So write it here 4. Then negative sign as it is. Then 7 also as it is of the second term. Then how many times I have to multiply 16 to become it 16? Of course, only one time. 16 is multiplied by 1, then it becomes 16. So write it here as 1. So 4 multiplied by 3, that is 12 minus 7. 7 multiplied by 1, 7. 12 minus 7, that is 5 by 16. Denominators is same. Simplify the mixed numbers, that is the 4, 2 by 3 minus 1, 1 by 6. So first of all, as the previous episode, we have already discussed how to convert the mixed number into improper number. repeating again. 4 is multiplied by 3 and then 3 is added into 2. In this this is the anti-clockwise process, and here I already write again once again, this is the multiplication process. You have to insert here the multiplication sign while between 4 and 3, and while in 3 and 2 you have to add the sign of the addition here. So using the Bode-Mess rule here, once again 4 multiplied by 3, 12 plus 2, 14, 14 by 3, denominator still remains the same. Again solving this by also the same way here, 1 multiplied by 6 plus 1 divided by 6, 6 plus 1, and that is equals to 7. So this is the term finally taking the LCM, that is the 3 and 6, LCM is 6. So write the first term as it is, then how many times if I multiply how many times 3 is multiplied with some number, then to make it 6. 3 is multiplied with, if 2, then it becomes 6. So 3 is multiplied with 2 to make it 6, minus sign as it is, 7 as it is. And how many times if I multiply with 6 to become it 6? If I multiply with 6 into 1, then it becomes 6. So write it here 1. So solving this very simply, 14 into 2, 28, minus 7 into 1, 7, and 28 minus 7, that is equals to 21 divided by 6. And this is the improper fraction. This is answer but in improper fraction. Remember that if our question demands that these are the two mixed numbers, and answers should be also in mixed numbers. If it's okay, if this is not mentioned in question, then maybe it's okay. But if you need to convert back, then simply conversion is required, as discussed in the previous episode. 21 is taken inside of the square root and 6 is outside. Dividend is always outside. So 6 is multiplied with 3 and answer is 18 and the remainder is 3. So that this is the clockwise conversion, and this is a 3 and 3 by 6, and 3 by 6 can be cancelled out by cancellation process, and this is divided by 3 into 1 and 3 divided by 2 to make it 6. So 3.5. This is the answer. And now this is your homework. Some questions I had added. You can see that here, if 3 terms are added or subtracted are available, simply Bode-Mess rule, and first of all you need to convert all these terms and simply add first 2 terms, add and then subtract the total result from this, and this is your answer. And answers are still available, and if you still found any difficulties, we will discuss it next time. So watch, learn, grow, see, stay tuned, and meet you in the coming episode.